In this video, I'll show you how to generate all strings with n match parentheses. For the file name, the input is n, a number of open parentheses, open left parentheses, and the output is all combinations of n match parentheses. Every open parentheses needs a close parentheses. So, for example, when n is 1, the output would just be this, because it's the only possible thing to do with one left bracket and one right bracket. And the reason why you only have one left bracket and one right bracket is because n is only 1. When n is 2, these are the two options. And it has these two options because it needs to use 2 left brackets and 2 right brackets for both these options. For when n is 3, it has these 5 options. All of them having 3 left brackets and 3 right brackets. For an observation, let the number of available open parentheses be non-variable, which starts at n. And let curr to start with empty string, so curr will start with this. Curr stands for current. In our example below, n is equal to 3. When you add a left parentheses, number available will be lose 1 and number unclosed will be plus 1. Because when you add left parentheses, it will be adding an unopened one, and then because you're using one of the number of available left parentheses, number available will have to go down 1. When you add right, number available stays the same because number available only tracks the left parentheses, and number unclosed is plus equal to 1 because it's adding 1 which isn't closed. Possible states. State 1, when number available is 0, it could only add a right, we can only add number unclosed right to curr to balance all open parentheses. Example, when n is 3, number available is 0 and current is equal to this. Number unclosed is equal to 2. You can only add 2 right brackets to curr, and then curr becomes this. 2 right brackets because number unclosed is 2. Those are the only parentheses you have left. Possible states number 2. For state 2, when number unclosed is equal to 0, you can only add the left bracket to current because the number unclosed is 0, so you need to add 1 to make it not 0 unclosed. For example, when n is 3, when number available is 2 and current is equal to this, number unclosed is equal to 0, you can only add left to current, then current becomes this. For possible states number 3, when number available is not equal to 0 and number closed is also not equal to 0, it has 2 choices. Choice number 1 is to add a left bracket, then number available minus equal to 1 and number unclosed will plus equal to 1. For example, when n equals to 3, number available is this, equals to 2, and current equal to this, number unclosed is equal to 1. After adding a left bracket to current will now be equal to this. For choice number 2, you could add a right bracket, then number available stays the same, and number unclosed minus equal to 1, decrements 1, and so for example, when current is equal to this, it will add a right bracket, so current will be equal to this. For the algorithm, function generate parentheses will take n, which will be in this case 3. Generate parentheses is a derived function. Because n is not 0, this statement does nothing, and then it will initialize current to be an empty string, and it will initialize number available to be n's value, which in this case is 3. It will initialize number unclosed to be 0. Then we'll call its helper function gen parentheses helper, which will take the input of the current curr, the number available, which would be 3, and number unclosed, which would be 0. Function generate parentheses helper takes the number of current, number available, and number unclosed that is discussed earlier on the left side, and so current would be empty string, number available would be 3, and number unclosed would be 0, and the output is every combination using 3 left parentheses and 3 right parentheses because it's 3 because n is 3. Over here is a tree which shows what the 3 things are, and each little box shows it at a time. So currently current is empty string, num available is 3, and num unclosed is 0. Because num available is not equal to 0, it will not go into if statement, and because num unclosed is equal to 0, it'll go into if statement and call itself to go to the left. Just this time, current has a left bracket in it, and num available minus equal to 1, so it would be 2, and num unclosed is plus 1 because now there's one unclosed thing, and num available is minus 1 because it's used one of its left brackets, one of its 3 left brackets. After that, because number variable is not equal to 0, it will not go in here. And because number enclosed is not equal to 0, it will not go in here. So I'll go in here for and go to add a left to current and decrement number variable and increment number enclosed. So now current will look like this, and number variable is 1 and number enclosed is 2. Then because number variable is equal to 0 and because number enclosed is equal to 0, it'll add a left again to current, and it'll decrement number variable and increment number enclosed. So now current will look like this, and number variable is equal to 0 and number enclosed is 3. Because number variable is 0, go into this statement, and that means I used up all the left brackets. And I'll then add the amount of not closed left brackets and then close them by adding right brackets. And that makes it so all 6 brackets are used, and it will return that. Then backtrack to over here on the tree to process the other option of adding a right bracket for this. And then you'll add a right bracket, and number variable will stay the same because it didn't lose a single left bracket, and the number enclosed will minus 1 because adding a right bracket will close 1. And then because number variable is not 0 and number enclosed is not 0, it will add a left bracket, and number variable decrements and number enclosed increments. So now there'll be this. And then after adding that, number variable is equal to 0, so it'll return the extra right brackets needed. So I'll add 1 right bracket and 2 right brackets because there were 2 left brackets that were unclosed. So then it will return that, and that happens to be this. And then I'll backtrack over here on the tree and process the other option of adding right bracket. So I'll add a right bracket, and then number variable stays the same because it's not using a single left bracket, and number enclosed decrements because it's closing one of the open left brackets. And because of that, number variable is not 0 and number enclosed is 0. It will have to add a left bracket, so number variable decrements and number enclosed increments. And after doing that, that'll make it so number variable is 0, so it'll add 1 right bracket because the amount enclosed is 1. So I'll close that with 1 right bracket, and that makes it so all 6 brackets are used, so it'll return that. So that will return this. Backtrack here and process the other option of adding a right bracket to current. So then after adding a right bracket, it will then have number variable stay the same and number enclosed decrement. So then it will add this to the tree. And after that, number variable stays the same and number enclosed number variable is not 0 and number enclosed is 0. So I'll add a left bracket, and it will decrement number variable and increment number enclosed. So then it will add this to the tree, with current being this, and then number variable and number enclosed is 1. And then because number variable is not equal to 0, this statement does nothing. Because number enclosed is not equal to 0, this statement does nothing. And then it'll add a left bracket to current, and then it'll decrement number variable and increment number enclosed. So then it'll add this to the tree. After doing that, that'll make it so number variable is equal to 0. So then it'll then add 2 right brackets because two of them are unclosed, and it'll add, and so add 2 right brackets, making it use 3 left brackets and 3 right brackets, the amount it needs to use, and then it will return that. So then it will return this right here. And then I'll backtrack over here, and then we'll process the other option of adding a right bracket to this current. So I'll add a right bracket to that current to make current equal to this, and number variable will stay the same and number enclosed will decrement. And then after that, number variable is not equal to 0, so this statement does nothing, and number enclosed is equal to 0, so I'll add a left bracket, and number variable will decrement and number enclosed increments. And after doing that, that makes it so number variable is 0. So return that, return current just with we'll add 1 right bracket because there is 1 unclosed left bracket. So that would be the final thing it returns. Then after returning all that, it'll have returned all this stuff on the left side, not the stuff on the side, being this, 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 and this. So the output would be this. And then it will return that. Over here it returns the output of that function. The output of that function was this. So the output would be this. The end.